Hey guys, it's Vinod. Today we'll be doing differentiation. I'll start by first explaining to you about the first principle of derivative. Then we'll do the polynomial differentiation. We'll look into product rule, quotient rule, and also the composite. Okay guys, before we go into the first principle of derivative, let's look at how to find or solve questions dealing with limits. Now, what do I mean? Questions like this. Now, how do you do a question like this? What do all this words here, this limit, the x with arrow 2, what do all of this mean? Now, basically what you have to understand is that when you say x is approaching 2, that means x is not equals to 2. But x is very, very close and very, very near to 2. That means x can be any number such as 1.99 or 1.9956, 1.999967, or it can even be 2.00001. So if you look at all these numbers, they are actually very close and you can easily round them off to 2. But are they 2? They are not 2. So that is what x approaching 2 means. It's closer, it's really getting close to 2, but not 2. So in cases like this, we will do what we normally do. So what do you do when you have answers long like this? You round it off to 2. So what you're going to do now, we're just going to take a 2, substitute into the x. So this is how you deal with this question. And the answer is going to be, that's the answer. Okay, is that easy? Quite easy, isn't it? Now next question, I'll do it a bit more faster. So how do we do this now? First, substitute x with -2. And what do you get? And the limits are just whole numbers. You can easily substitute them and get answers. Now, the complication comes when you're dealing with infinity, because infinity is not a number, it's a concept. And how do you deal with that? Now, whenever, how I deal with that is normally I'll think about, since high school, this is what my concept is. When you think about infinity, it's an extremely huge number, but there is no certain number. But that doesn't mean you cannot think of a number. So I normally think about a million. I take it as infinity when you're comparing to 1 or 2. But 1 million is not infinity. Infinity is much bigger than that. But you just use that for the sake of calculations. Easier for you. Okay? So now, let's look at this question. Limit as x approaches infinity for 3x squared. What will be the answer? Now, infinity is an extremely huge number, and when you're going to square that, is it going to get smaller or bigger? It's going to get much, much bigger. In which case, the answer is going to be just infinity. And we are done with that. Okay? Easy. Now, next question. In this case also, you can just substitute infinity into the x value, just like what we did here. Okay? So what's going to happen now? I'm just going to put 1 over infinity. What do you get for this? See, 1 over an extremely huge number is going to be close to 0. Am I right? Now, if I'm not sure, let's try this. If I have 1 divided by 10, then 1 divided by, say, 100, 1 divided by a million. What's happening to all this? You're going to get 0.1. Do you realize the bigger the value gets, the denominator gets, the answer is approaching 0 and it's getting much, much closer to 0. So imagine if for 1 million it's already so close to 0, what more when you have infinity, a number which is extremely large? So the answer is definitely going to be is equals to 0. Easy. Okay. Now, this is easy because you already have infinity here, you're going to substitute that. Here we know it's approaching 0. And there's only one. The limits are just whole numbers. You can easily substitute them and get answers. Now, the complication comes when you're dealing with infinity. Because infinity is not a number, it's a concept. And how do you deal with that? Now, whenever, how I deal with that is normally I'll think about, since high school is what my concept is. When you think about infinity, it's an extremely huge number, but there is no certain number. But that doesn't mean you cannot think of a number. So I normally think about a million. I take it as infinity when you're comparing to 1 or 2. But 1 million is not infinity. Infinity is much bigger than that. But you just use that for the sake of calculations. Easier for you. Okay? So now, let's look at this question. Limit as x approaches infinity for 3x squared. What will be the answer? Now, infinity is an extremely huge number, and when you're going to square that, is it going to get smaller or bigger? It's going to get much, much bigger. In which case, the answer is going to be just infinity. And we are done with that. Okay? Easy. Now, next question. In this case also, you can just substitute infinity into the x value, just like what we did here. Okay? So what's going to happen now? I'm just going to put 1 over infinity. What do you get for this? See, 1 over an extremely huge number is going to be close to 0. Am I right? Now, if you're not sure, let's try this. If I have 1 divided by 10, then 1 divided by, say, 100, 1 divided by a million. What's happening to all this? You're going to get 0.1. Do you realize the bigger the value gets, the denominator gets, the answer is approaching 0 and it's getting much, much closer to 0. So imagine if for 1 million it's already so close to 0, what more when you have infinity, a number which is extremely large? So the answer is definitely going to be is equals to 0. Easy. Okay, so now we're going to look at a question where you have x in numerator as well as denominator. So let's see. Now, how do you solve this? So, you cannot have x here, that is a rule. So, I'm going to divide both numerators and denominator by the highest power of x, which is in the numerator. So, it's going to be x squared. X squared. How do you do this? Divide x squared, and the entire thing is over. Okay. So here I'm going to cut this off. So that leaves me with and you realize if I substitute infinity to this is going to be 0, similar to that, because anything divided by a large number, it's going to be 0. So this is going to be 0. So what is left there? It's just 5 over 3. Now, is that easy? Very easy, isn't it? Okay. Now, one more question. How do you solve this then? Again, ask yourself, is the x, the term x in numerator or denominator? In this case, sorry, it is still in the denominator, so you can just substitute them. What happens here then? It's going to be infinity. You can write it, but just to make you understand, I'm just writing this plus 10. Correct? Basically, there are two large numbers, extremely large numbers. When you plus them, the 10 is not going to matter. The entire thing is going to be infinity. So it's going to be 5 over infinity. Now I'm repeating this. You can't really plus this, mathematically, because infinity is just a concept, it's not a number. But I'm doing this just to make you understand. When you take a very, very huge number and you plus with another huge number, the 10 decided is not going to matter. The answer is going to be another extremely huge number, which is infinity. So 5 divided by that is going to be 0. Okay, now that you're familiar with dealing with questions that has limit, now I'm going to teach you how to do differentiation using the first principle. Okay, so let's say we have, I'll start with an easy question first. Let's say we have y is equals to 7x. The first step is substitute y with y plus delta y. Here, you're going to substitute x with x plus delta x. If there are more x on your right, you substitute with each term of x with this. Okay? Now, next step is expand this. So, y plus delta y is equals to 7x plus 7 delta x. Okay? Then, we are going to make delta y as the subject. So, the rest you have to move them to the right. So, delta y is equals to now, do you realize y is given as 7x? Substitute that into this. So this is 0. That leaves us with, okay, so bring delta x the other side, so it's going to be delta y over delta x equals to 7, and this is not your final answer because you want to find dy dx. This is delta y over delta x. Now, how are dy dx related to this? Dy dx is equals to limit as delta x approaches 0 for delta y over delta x. So now we're going to write back limit as delta x approaches 0. What is delta y over delta x? 7. Now, do you have any numbers beside that? Do you have any delta x? So if there are no delta x, you don't have to substitute 0 anywhere. The final answer is just going to be 7. That's it. Now let me give you another question, probably a bit more complicated than this. Number 2. See if you have now, how are we going to use the first principle for this? It's the same concept, okay? So don't get panic. First, y, you're going to substitute with y plus delta y. X squared, you're going to substitute with x plus delta x, the entire thing squared, okay? Then plus 3 bracket x plus delta x, okay? And finally plus 10. Now, you know what to do next. Expand this. Okay, plus 3x plus 3 delta x plus 10. Now, can I explain this? Of course I can. I'm sure you have learned this in lower secondary. Just gonna make a line. X times x is going to be x squared plus x times delta x, another x plus delta x, plus delta x squared. Okay, plus 3x plus 3 delta x plus this one. Now let's continue. X delta x plus x delta x is going to be 2x delta x. So here when you expand, you're going to get 5x squared plus 5 times 2 is 10x delta x plus 5 delta x squared and the remaining ones here. Okay guys, now are there any similar terms which you can plus? From what I can see here, you have 3 delta x, and actually there's nothing that you can do, so just leave it here. Now next step, we are going to bring that y the other side. So delta y is going to be 5x squared plus 10x delta x plus 5 delta x squared plus 3x plus 3 delta x plus 10 minus 1. Now what are we going to do with this y? Substitute with the with this expression given in the question. Minus, see when you have a minus here, right, always put a bracket, it's easy. And you close it. Now we're going to bring the negative in for each term. So I'm going step by step so that you know what's happening. I can easily skip a few steps and finish it up quickly, but you might have a lot of questions. That is why I'm doing step by step. Okay? So just write back all this. Now, negative positive is going to be negative 5x squared. Negative positive is again going to be negative 3x. Negative positive is going to be negative 10. Now, do you realize this and this cuts off? 3x and negative 3x cuts off. 10 and 10. So, what are we left with? Delta y is equals to delta x plus delta x. That is all we are left with. Am I right? Now, how are we going to move the delta x the other side? First, we see all of this has 1 delta x. So I'm going to factorize. What is left inside? Take the lowest power of delta x always. If 1 delta x is out, there is 1 more left, right? So that I'm going to write here. Here no more, just 3. Move this to the other side, it's going to become delta y over delta x equals to 10x plus 5 delta x plus 3. Now you know what is the next step. We are not done yet. We are going to write that. So I'm going to erase that and do it that so it's easy for you to understand. So the quantity is here. Okay, now I'm going to say dy over dx is equals to limit as delta x approaches 0 of delta y over delta x. Now we know delta y over delta x is this, just substitute that inside. So, you know, I've told you before, whatever the variable is, If it's a whole number, just substitute that whole number into it. So here it's going to become delta x, I'm going to substitute 0. So what is the final answer?